he has donned multiple hats at the university, from being the former dean at the School of Environmental Sciences to being the director of transdisciplinary research cluster at the university itself. He has worked on multiple aspects in the air pollution space, and there are just a few important ones that I would like to list. He was one of the first scientists who actually reported the occurrence of acid rains over the Indian Ocean, and his work kind of highlighted what are the complex interactions between atmospheric dust, pollutants, and environmental processes. He has done, multiple works, and his contributions, especially on the transboundary and long-range transport of air pollutants to the Himalayas and South Asia, have been quite highly significant. More importantly, he has also, he has had various contributions as an educator to inspire future scientists, like a lot of us are out here, and also policymakers, for building a knowledgeable workforce towards the whole tackling of environmental challenges that we're facing today. Again, he is, considering his research background, there are multiple awards that he's won. He has also, expanding on the transdisciplinary nature of his work. He has been an active member of the Environmental Pollution Control Authority, which is a regulatory body under the Supreme Court of India. And also, worked on multiple domains. Honestly, I can go on and on, publishing a number of books and publications and so on and so forth. But I think people are more eager to listen to you, Professor, to listen to your talk. They're eagerly waiting for it. So I think I will, yeah, I'll hand over, it to you, and maybe you can, uh, talk on air pollution issues and, remote sensing and how it will work. So over to you, Professor.
Thank you very much for a nice introduction. I'm just sharing my slides.
Professor, you're not very audible. Can you speak up a bit louder?
Now, is it okay now? Hello?
Yeah, it's much better now.
Hello. Okay, I will just make it more closer then.
Sir, a little bit more.
Sir, we are not able to hear you.
This is the maximum from my side now.
Your voice is very faint. Professor.
आवाज नहीं आ रही Is from this side or this? No, this is size.
To the participants, please use the chat function to ask questions after the talk.
Hello. Hello.
Yes, Professor, we are able to hear you now.
It's a good one. Actually, from your side, it seems that you have to do. It's showing only half. Okay. Good morning, everybody. Thank you very much, Future Earth, Madhusudan, and the team for inviting me for this talk about awareness. Are you able to see my slides?
Yes, sir.
Okay. So, topic was given about air pollution in Himalaya. In fact, I have included Himalaya, South Asia, and Oceania region because this is the region where research is least done compared to the West or even mainland India. Himalaya region, South Asia towards Oceania region is less investigated, and I thought of being member of AOGS, Asia Oceania Geoscience Society. Let us think about something to be done in future about Himalaya and towards South China Sea. If you look at this map showing Himalaya different parts, we have different nomenclature for different Himalayan ranges. My work which I have done is related to Indian Himalaya, northern, central and eastern Himalaya ranging from Jammu Kashmir to Himachal and Uttarakhand and northeast region. As you know, Himalaya are very sensitive, vulnerable to any kind of change, and we are knowingly doing a lot of changes in Himalayan ranges. For example, urbanization, deforestation, all these activities are really threatening Himalayan ecosystem. Himalayan ecosystem, as you see below uh, figure, it shows it's a highly sensitive area as defined by the project which was dedicated for this particular aspect, rapid sea, regional air pollution in developing countries. So we have to
Sir,
take care.
uh,
Hello.
hello, sir. Just a small interruption. Can you please press the slideshow button on the slide?
Yeah. Now better.
Just a
Hello.
second. It's not yet updated. It's not yet. It's not showing the entire screen.
But from my side, I have done.
Okay, sir.
Probably no.
Okay.
Or shall I do again? Now we see because sometime it hangs. Better? No.
There's no change, sir. But okay, you can continue, sir. I won't interrupt.
So we are really putting a lot of things in Himalaya, and the carrying capacity of Himalayas is very, very low, but we are not caring for that, for land and also atmosphere. If you look at this slide, it shows various unusual events, unusual news about Himalayas. It's a very common news that one melting of glaciers. Glaciers are melted, continuous receding due to global climate change, and that global climate change is a consequence of fossil fuel burning that has been approved by IPCC. And that is not good for our region, also not good for globally also, because if this kind of receding is there, the hydrological cycle will and hydrological cycle basically has a very important role in our survival itself, because whole atmospheric dynamics, our survival depends on moisture content, but in a appropriate ratio. Some people say the melting of glacier is good for India because India has only two sources for water. One receding, means melting of glacier through rivers. Another one is through monsoon. But the rate of receding is not good. It's so quickly happening that we have to little bother for that. Then another news you may be hearing, those who are from North India, basically, the frequent cloud bursts. And frequent cloud bursts are happening in Himalaya region. And that is also, slide is not changing. Hello? Hello?
No, no, sir. We are
So
still
better.
in the
So
slide of the map.
I think I will then show in this mode probably. Slide is changing in this mode.
Yes. Yes, yes.
Okay,
Now
this
it's
is
changed.
okay. This mode is better. Are you able to see my slide of melting glacier?
Yes, now we can see recent
So I
unusual
will show
news
in
highlights
this
about
mode.
Himalayas. The slide.
Early when I highlight, when I
Yes.
use that, some problem is there. So I will use this mode.
Yes, yes,
Bear
sir.
with
Sure,
me
please.
if you are having very small photo picture. So frequent cloud bursts in Himalaya region are indicating basically a lot of particles were from gas to particle conversion, and then that is really giving this problem. And we have done a lot of work and written about this problem. Then landslides in Himalayan region. So many uh, hotel construction, building construction, deforestation happening. The whole fragile Himalaya is vulnerable to landslides, and frequent landslides are there, and people are suffering from basically these road problems. They are not able to travel from one place to other places. And Cherrapunji, which was supposed to be the highest rainfall place, is no more. So this is something indicating that Himalayas are disturbed. Himalayas are under threat. Why? Because you see, already everybody knows that traffic, tourism, number of cars, they are crossing the carrying capacity, and the dumping in the Himalayas. You see, this way we are spoiling Himalayas. So air pollution together with solid waste. And the air, what we are finding, it's not the local one. The air is traveling from very far places like Northern Atlantic Ocean, Middle East. That air is coming to Himalayas and affecting the soil, vegetation, forest through snowfall deposits. You know, when westerlies they come during winter season, they carry pollutants, and you know Europe has a lot of acid deposition, sulfate nitrate, so we got very high deposition in snow over Himalaya. So long range transport is very important and playing role in Himalaya degradation of ecosystem, because as I mentioned earlier, the soil of Himalaya system is very sensitive, and that if acid deposition is there brought by these air masses from far places, it really threats to the ecosystem. This study, we did 2 studies over Himalaya, snow chemistry. One including Jammu and Kashmir and that very famous place called Gulmarg. One of my students, Bablu, did that, and we found that air masses were coming from 6 directions, and they have different kind of effect, different kind of chemical content they had. Mostly 40% air masses originated in northern Atlantic Ocean, 23 from Africa, 10% Middle East, then 6% from Europe in general, then 13% from India, and 8% from Nepal. And we found that the pH was very low when air masses were coming from west, means northern Atlantic Ocean. Acidic pH, as I mentioned, is very harmful. Already Europe and North America, they are suffering from acidic deposition. Himalaya, if is done this kind of deposition at continuous rate, will have problem, and Himalaya problem is our problem. So we have to take care, and we should be alert. Our government, policymakers, they have to be alert. Even public also should understand the difference between normal pH, which is seen all over India, that is very high compared to the acidic pH brought through these air masses. We then compared the acidic content and pH of our study done during 12 and 13. That we compared the study reported in 85, 86, that time, means around 20, 30 years back. And we found that pH of snow deposition was changed 0.8 unit, reduced. That is very huge. 0.8 is very huge unit for pH change. And we found that non-sea salt sulfate was increased 114%, nitrate 109%, ammonium and calcium little less. And these figures basically are very alarming, and we have to take a note of it. It should not be taken for granted, something we have to do. Another study we did, Anshu Sharma, one of my student did, including Jammu, Kashmir, Himachal and Uttarakhand side. 3 sites and similar type of features we noted. And the sea, you look at air masses coming from northern Atlantic Ocean, Middle East, all these directions, and getting deposited over Himalaya region. Then we basically, there was some kind of news. If you understand this news in Hindi, they say that Europe and Middle East air masses are in bringing pollution, and pollution is almost 2.5 times in it's 2 times in 2.5 decades. When we talk about South Asia, my domain has been South Asia. Earlier, I was a South Asian coordinator of a project, UNA project, where we had sites in Nepal, Maldives, India. Recently, I have completed a project on South Asia nitrogen that we had site in all South Asian countries and in India. So in general, South Asia is having a different picture compared to temperate regions due to very high dust. And that dust is very interactive. It affects gas to particle conversion of SO2, NO2. But at the same time, South Asian region is having very different kind of geodiversity. Basically, it's having very high snowfall in Himalayan region. Then middle part is agriculture, and west is Thar desert, east is high forest, south is oceanic. So it's a kind of mixture of variety. Cannot be taken for granted by making one rule for environmental conservation, sustainable development, or any kind of industrial control. So we have to consider different types of activities and also the natural diversity of the South Asian region for making it. I will show you some of the pictures where I was involved. This is about Honey Madu, where we were taking measurement during that UNEP project. And this project basically had a super site in Honey Madu, Maldives, where you can see this is Honey Madu. If you see the India with respect to India, then this is super tower where all equipments were mounted. And this is a beautiful view of Honey Madu, where you can see here our wet only collectors were installed, aerosol samplers, different kind of. Then this is slide showing recent South Asian project which we had just completed. This one, we had sites in Maldives, Bangladesh, Sri Lanka, India, Nepal, Bhutan, all, and all these basically workforce included basically youth. As I understand, this program is for awareness, and mostly youth are participating, and they have basically responsibility to see what type of picture we have, what picture we are going to have future Earth. Future Earth program itself is reflecting that what is Earth today and what will be it tomorrow, what kind of changes are happening and what rate the changes are affecting natural composition of Earth, including solid Earth, atmospheric Earth. Then if you look at this, is another observatory we had in IICT Hyderabad. We developed aerosol sampler, semi-automatic rain collector, all these. This was basically the pictures are from a workshop. We did international workshop of that observatory. So in general, basically, if you see South Asia is having different message, which we did two decades almost. We struggle with the acid deposition, saying that we have very different picture from US and Europe. We had very long collaboration with Sweden, Stockholm University, and we proved that soil dust interference is very huge, making calcium sulfate as a main ingredient of rain chemistry, whereas over Indian Ocean things were different. As mentioned in the introduction, that time I reported first time acid rain. That was a surprise to me when in 1995 Indo-X cruise were there, then 96, 97, 98, total 4 cruises. I measured pH of rainwater very low. That time, in fact, I myself was not having confidence whether it's right or wrong, something wrong, went wrong with the collector or the chemicals storage. But repeatedly we got this pH. This was peculiar, very different from the terrestrial mainland, Agra, Delhi we used to have. So this contradiction, anomaly, basically was validated with different kind of experiments which you can read my papers. Here is no time to say, but this proves that Indian or South Asian region is very different from atmospheric chemistry point of view, and we have to have different kind of approach while tackling air pollution in this region. As I mentioned, in the Indo-X, we used to go by Sagar Kanya, and we used to measure pH at different latitude, longitude. So coordinate-wise, we know the pH, and based on that, we develop some contours. But this is the problem with this type of approach of data analysis. You don't get very comprehensive picture about it. Similar thing, we plotted contour by using South Asian nitrogen hub data, and we got this picture. As you see, this kind of approach is reflecting some kind of incompleteness in the map. But if you look at this map, which is remote sensing, it's taken by Trophomi satellite. Basically, this is European tool, and they see the NO2 map. NO2 map is so impressive here. It gives a complete picture, spatial distribution of NO2 compared to what you have, what I showed you point measurements. So ground measurements, they are really needed, but remote sensing data gives a very clear picture, a spatial distribution where you can think, you can use it for policy, and how it is done. Many of you may be knowing that ground-based measurements, when we do, we use some kind of relativeness with the sun, and then a column, we measure columnar density. But satellite is observing at a larger area, and you get a very good picture. For example, if you have this, the light is irradiated with different type of objects, and satellite receive that signal, and this is how a better picture is captured by satellite, and very impressive picture. For example, this global map for biomass burning, pollution and dust, haze pollution, biomass burning in fall, different season, different pictures you get, very comprehensive, very clear, and that gives a clear message that apart from ground truth, ground observation, satellite data is really complete, which we should use. We should club coupling of ground-based measurements with satellite data is necessary. If you look at the PM 2.5, if you measure PM 2.5, you get points like this, which is again very incomplete picture sort of thing, but this picture right side is received through in satellite, and this is a very complete picture and clear cut. It shows that how much PM2.5. So this is the beauty of remote sensing data, and also you cover larger area with sometime, you know, in measurements you are not able to capture certain site due to some problems. Sometimes site is too away, sometimes electricity problem, logistic, other issues are there, but you can cover with the remote sensing this, and it's a convenient once you start. That is, so one my student is working on this aspect sort of. And as I mentioned, you know, long range transport is affecting Himalaya, even Indo-Gangetic Plain, Bay of Bengal, or the, so there is a need to use remote sensing in long range transport versus local sources of air pollution. If you look at this slide, it says that dust from Mongolian desert reaches US in 21 days and 11 days, and you can see this transport color images. very impressive. So this is what remote sensing does. It is so narrow, means resolution is so fine nowadays, 7 by 7 kilometer, using this topography, that you can, even smaller objects you can differentiate. So this is what I just wanted to pass the message, that Himalaya, South Asia and Oceania region, when we talk about, Oceania, this is the region where we have to focus. Japan, including Oceania here, I mean more of Asia, Oceania, Japan, South Korea, here in comes Singapore, Thailand, India, Malay, Sri Lanka, these regions. Because this is required for air pollution, new research point of view, as well as, security point of view. Lot of even movement happening through this junction. It's a huge junction here also. Mali also huge junction for sea traffic and sea ship. They use a lot of diesel, so a lot of carbon, and also the biomass burning coming from Indian regions. All this comes during this winter season, especially. This whole region gets a lot of age, that we have to really find out what satellite data says. So to summarize, Ved, I just want to reiterate that local and long range transport of air pollution is a really threat in Himalayan system, and we have to take care of that. We found that sulfur oxides and nitrogen oxides were higher compared to the ammonium. That says that SO2, NO2, which are mostly emitted, they are carried uh, uh, by the air masses to Himalaya. And there is a clear-cut difference between local versus transported these chemical constituents. And also this Indian Ocean is getting affected by the air masses, which we found, which somehow I missed that slide, but there, we participated in ICAR, integrated campaign on GHG and aerosol radiative forcing by ISRO. In that, we found that Bay of Bengal was more polluted than Arabian Sea, and that to Bay of Bengal, northern part of that. So this has to be identified further towards how much it goes up to Singapore and that South China Sea, how these air masses. So the countries which are really affected, they can be invited to participate, develop some new program and use remote sensing data. Now, there are some action points which I am suggesting what to do. India government as a whole, or the region, South Asia or Asia, Oceania region as a whole, required, because we need to have studies on air pollution in Himalaya and Asia Oceania region, dealing with human health and climate change, which is important, which basically new area where we can generate new knowledge. Accordingly, we can take action. Then there is a need to create Himalayan Council similar to the Arctic Council, so that we can protect Himalayan very dedicatedly. Then there is a need to develop a treaty like LRTAP happened in Europe, that is for long range transport. These different countries, how much they are exporting, how much they are importing, and accordingly they get compensation. And there is a need to develop a team of researchers who are really interested in this aspect, that is where youth can play a very important role in that one. And also then we develop, this will have a lot of new collaborations. For example, we can develop a program like Indo-Singapore, Indo-Taiwan, Indo-Nepal, these, because these are the countries having a lot of very active teams, a lot of funds, a lot of interest, and probably also their ideology matches with India, then there is a need of funding and a coordinating agency as usual to execute anything. So with these words, I thank you very much. And at last, I just invite you all people to AOGS 25, which will be held in Singapore next year. Thank you very much. If you have any query, please. Hello.
Thank you. Thank you very much, Professor. Let me now ask all the participants, if you all have any questions, you all can either put it in the chat box or you all can raise your hand and, you all can ask. There is one question here that I see, Professor. How fly ash particles from thermal power plants will neutralize the acid rain, and what is the composition of fly ash?
See, fly ash is different than what I was talking about, the dust. Dust is coming from open soil like agriculture fields. Then it is coming from road dust. And then it is coming from cements. Cements, they have more metals and that is not good for health, very similar to fly ash basically. Fly ash doesn't much help in buffering, but normal soil dust helps a lot because it has a lot of calcium carbonate, and that calcium carbonate reacts with sulfur dioxide and making calcium sulfate. So fly ash is a problem in air basically. That's why we have started making bricks for that.
Okay. Thank you, Professor. I hope, Kavita, that answered your question. If anybody else has any questions, I think Adish has.
Yes. I just wanted to know, how would you measure, how would you find out whether the dust from Mongolia is reaching the US? How do you find out in the, like, are there measurements that actually take the data samples from Mongolia and US, or is it just an assumption?
In fact, this is done by satellite data, and if you see the trajectory analysis and based on that, if you find out the dust is not only in Mongolia, there was a presentation dust from Middle East to reaching Atlantic from the left side. This one is from right side, other one is from left side. So it reaches, and then they collected samples, and then they identified based on the traces of a particular desert. For example, Mongolian desert, you have some composition of that dust, the particles, and then you are receiving those particles, that composition. So that ratio, if it is enrichment factor or any kind of approach, you find out and then match with that, and then see the trajectory through that these particles are collected. This is one way.
Okay, sir. Thank you. Shruti, there's one more question by Jaya Chitra.
Yeah, so I think this is on the famous Delhi air pollution. Speaking of air pollution in Delhi, how safe are other cities and what are the steps that can be taken to prevent this? That's the question. Also, sir, do you think, RSGIS can kind of help us get a better sense of, since you have spoken so much about wind and how air travels, do you think those kind of mechanisms will probably help us come up with better solutions? I mean, I'm just thinking out loud here.
See, let me tell you first one that Delhi pollution is huge, but at the same time, other cities also have similar pollution, but not in news. Delhi being capital is in news, quite obvious. You know the regions, but I have done a lot of work on Delhi and found that Delhi is having three types of pollution. One, dust. Being in North India, near third desert, naturally particles load is very high, air quality is poor and it will remain poor. Only that rain can help. When rain is there, air quality is much better because rain removes particles. That is what we have demonstrated, and I have suggested based on that Delhi should have two big lakes like Usman Sagar and Himayat Sagar, where water will be evaporated. Sometime convective rains will be there, and rain will remove particles. And one of my students has modeled also the bigger lakes remove more PM 2.5 compared to smaller lake in Delhi NCR area. So this is something one. Another pollution is carbon. Carbon is coming from plastic waste burning, brick kilns, tire pyrolysis, then vehicle everywhere. I mean, carbon, if we control Delhi air pollution, we can control. Another problem coupled with that is chlorine. That is really affecting ozone. Ozone levels were low, and during pandemic, after even GRAP 1 we implemented during EPCA 2018, ozone levels became high because we stopped carbon emission from plastic waste burning, illegal plastic tire burning. So this is how Delhi pollution can be controlled by for dust. You control construction sector. Then for carbon, you control brick kiln and plastic waste burning. And for nitrogen, you control all the water logging, sewer, water logging on roads, a lot of nitrogen pollution. Then coming to GIS, remote sensing data, definitely this will help. As I showed you, when we measure, using any kind of manual sampler or automatic sampler, we get only the information about that particular point. And those points basically have bias. What is that bias? The one side is two, uh, 2 meter away from road, and we have put a sampler at first floor. Other side, we have 20 meter inside road, and we have put our sampler on ground floor, near to ground floor. So that, sampling method is different for manual networking. So remote sensing provides at least uniform pictorial scene where we can believe uniformly without any bias. Then we can do ground truthing. That is better. So this is where remote sensing plays very important role. And because this is a recent tool, why not to use? That is what I am promoting. I am not remote sensing person. No, I am entering in that one. My student is working, but I realize based on my IndoX, ABC, CAP map, Rapid C, CAD program, I realized that remote sensing should be coupled with the chemistry of atmosphere work. It gives fantastic results.
Thank you. Thank you very much, sir. So, any other questions from anybody else? Okay, I don't see anything else, and I think we can close it from our end. So thank you very much, Professor, for giving your time and enlightening us about the air pollution and how RSGIS can kind of work at multiple levels to help us get a better understanding of the scenario itself. And more importantly, I think when we talk about pollution, we think very localized. And your insights on the whole long-range transport of pollutants, especially from a lot of other completely other regions itself. I think it was quite enlightening, and we really enjoyed listening to it, and it was also very informative for us. And yeah, so thank you very much, and also a huge shout out to Madhusudan and Adish, who were the ones who actually kind of organized this whole thing. I mean, so thanks a lot to both of you all, and thank you, Mr. Raj, for being a good support through this entire exercise. So thank you, Professor Kulkshetra.
Thank you.
Thank you very much.
Thank you, Professor.
Thank you. I enjoyed and hope everybody. I think what is the gathering here? Mostly students from.
So it's a combination of students and researchers and everything, and also from across different regions. So we
I can-
have, we have people from across Asia and other regions.
Yes,
Philippines, Bhutan,
Bhutan.
and Pakistan
Good.
also are participating today.
Very nice. Good. Thank you very much.
Thank you, sir.
Thank you. You have to